Thank you, Chair, and welcome, Mary. We've been really looking forward to listening to your presentation. Colleagues, as you all know, Professor Mary Scholes is at Wits University and a full professor in the School of Animal, Plant and Environmental Sciences. Her research activities focuses on systems analysis in a variety of disciplines, including soil fertility, food security, and biogeochemistry in savannas, plantation forests, and croplands. Mary is very wise on a number of topics, and I think it is timely that we recognize the sterling breadth of her work by asking her to join us this afternoon to deliver the science presentation during our AGM. You may recall we used to have the science talk and then we did away with it, but we feel that it's most appropriate to have one to celebrate the scholarship of some of our esteemed members within the Academy. With that, it is my pleasure to invite Professor Mary Scholes to address us on sustainable Africa, weathering global change. Over to you, Mary.
So thank you all very much. Are you able to see my screen?
Yes, we can.
And
but
are you able to hear me?
Yes, wonderful. You got it now on screen display and we hear you clearly. Over to you.
Okay, so thank you very much. Thank you for inviting me to make this presentation this afternoon. And I will try and make it applicable to where we are currently in South Africa and where we are globally. So it's very important this year to understand sustainability because it is the International Year of Basic Sciences and Sustainability. So that's why I chose to talk on sustainability in South Africa, and then a play on words of weathering global change. Many of the things that we are now seeing as global change is very rapid response, which in the long-term history of our continent of Africa is certainly not what we would have seen over centuries. Where our continent is today, it has not moved for millions of years, and our soils have continued to weather in order to give us what kind of fertility we currently have in our soils, which in most cases are nutrient-poor soils, so therefore they won't necessarily meet the food security crisis or necessarily the industrial crisis. So if we think about weathering in terms of soil, it's an extremely slow process. However, we are going to have to weather global change very quickly because the rate at which temperatures are changing and the way rainfall patterns are changing, our response cannot be over centuries or millennia. They have to be at least decadal, if not within a year. And then how long do we have? And that's the important issue. How long do we have to weather these particular changes in our particular location? So what I would like to cover today is a little bit about the way that we now work in global change systems and to think about how we put all the pieces together, which is called systems thinking, and to embrace the International Year of Basic Sciences for Sustainable Development. And what that fundamentally means is how do we continue to use basic science, be it the products of basic science, which you then apply in a particular way, or be it the teaching of those basic sciences, which will generate a new cohort of academics and of people who will easily and seamlessly move into government or into industry. And this is very carefully linked to the Sustainable Development Goals. And one of the most important areas around that is called the just transition, which means it needs to be fair. It doesn't necessarily mean to be equal, but it should be equitable. And then I will speak a little bit about the specifics of what is happening, particularly to South Africa and the impacts, my own particular research interests in the forestry industry and food security, and then thinking ahead. So I would urge you to stay till point number 5, because I think that's the reflective part of what we as academics and as scholars really need to think deeply about in order to train new individuals and to contribute to our society. So if one defines sustainability, which is the definition from the IPCC, but that's the Intergovernmental Panel on Climate Change, but it's also the definition that many other organizations like the World Economic Forum, the Global Investment Trusts, and the World Bank, they use this definition of sustainability, which focuses on meeting the needs of the present without compromising the ability of future generations to meet their needs. And whilst they try to shorten this particular sentence, and I was involved in this negotiation, which is worse than any Senate meeting at WITS, is how to get these particular words to mean what you want them to say. And it really embraces the needs of the present. That's the people, the environment where we are currently, the economics, the politics, but without compromising the ability of future generations. And, you know, many meetings I go to take this particular definition so seriously that there is always an empty seat at the table at a very serious meeting, like even last week when I was at the World Meteorological Organization in Geneva. When we convene their research board, they have an empty seat on the board, which is the future generation seat. So, you know, it just brings to mind what we should be thinking of. And now many people talk about the 3 Ps, profits, planet, and people. And you may think that's a bit crass, but actually that's what it's about. And it is in that order. What are the financial profits versus the planetary profits, and how do people fit into that? So just to remind you of our South African context, which I'm sure you don't need any reminder of, we have I'm trying to find the right word, set of environmental conditions which often come upon us very quickly. Like the April floods in KwaZulu-Natal, we knew there were going to be floods. However, our early warning systems were not sufficiently deployable in order to save the lives that we should have been able to save and the damage to the infrastructure. So there is this urban city intersectionality, but at the same time, there are all the rural accommodations that we need to make in this country, and how many millions of people in South Africa who are not involved in the formal sector of the economy still have to make their way in terms of meeting the necessities of life. So just to put that in context. Now, this is what we would call a systems diagram, but it's a very simplistic diagram. There are a whole lot of what we call boxes, like biogeochemical change and climate change and marine resources. And there are a whole lot of arrows that connect all those things to each other. And the reason people think like this is that it it is well constructed to make sure that you don't leave out any of the pieces. This shows very clearly that we do live in a very connected world. Each of those arrows imply the connections. And, you know, I could have drawn this diagram and included the COVID pandemic, for example, and how quickly we had the spread of the COVID pandemic. But all of these particular areas interact with each other. So strictly speaking, I'm a systems person. This systems diagram shows you all the bits, but it doesn't really show you how connected the bits are to each other, because all the arrows in this diagram are of the same dimension. They're all the same little black line, which doesn't tell you if you break one of those black lines, if you break the line between marine resources and biodiversity change, what will the outcome be? Will you have complete chaos? Will it have no impact whatsoever? What will be the magnitude of breaking that connectivity? And being able to work out the magnitude of that connectivity and then act on it usually allows the improvement of the efficiency of the system, which hopefully will lead to the resilience. So in case you've never come across systems theory, which a lot of people step back and say, no, I don't work in a system, but actually you do, you just don't recognize it as a system. So you can have an object of interest and you can have a driver and an input, which is on the left-hand side of this diagram. And then you have another arrow, which is outputs and effects. That's not a system, because there is no reciprocal impact on the object of interest. This is not a system either. A impacts B, but that's it. Whether it impacts it in a minor way or a major way is not, you can't see it in this particular diagram. However, once you start getting the interaction of objects, like in this very simplistic diagram, where A impacts B and B impacts A, I don't have to tell you that in many cases, the way in which A may impact B might be completely different, may be a bigger impact, may be more sustained, may have a completely different set of outcomes to the way that object B impacts A. So this is what we try and measure in the various types of science, which is mostly related to climate change and the impacts on industry that I'm involved in. So to have a system, you've got to have at least two or more interacting bodies. So just to add a little bit of complexity, the easy thing is they have to be interacting parts in your system, and you have to have feedback loops. So in other words, we saw in the early diagram, A impacts B and B impacts A, but in what way? Positively or negatively, and to what magnitude and at what rate? So those are the kinds of issues we ask, and when we take measurements, we want to be able to answer things like, how much rain is there going to be? How much flow into the rivers is there going to be? How much absorption by the soils? And only once we get all those feedback loops can we then assess the impact in various communities. Most systems are complex, and out of this complexity comes what we now call wicked problems, which there are no easy solutions due to the trade-offs. And I was giving an example earlier to my students where in the 2016 riots we had at most of the universities in South Africa, where students wanted more money to go into NSFAS and to fund their education, that was a wicked problem. There was no easy solution. And for some people, the solution that was found was not very comfortable. The solution that Treasury came up with was to take money out of the health budget and redeploy it into the education budget in order to provide more money into the NSFAS financial aid system, which then served the needs of the students, but it didn't serve the need of future communities, and especially around the vaccination of the future generation. So wicked problems are essentially where you have these trade-offs where sustainability cannot easily be achieved. Unfortunately, many of those decisions, like the one that I've just given as an example, have unintended consequences, like the supply of vaccines for babies that could then no longer be vaccinated against very common diseases back from 2016, and even now, because of the emphasis on COVID, many of those other vaccination programs have actually really fallen into disarray. One of the things about a system are what we call emergent properties. And the most common example that I give, which people tend to understand, is your refrigerator in the kitchen. You have a refrigerator, which the primary purpose is to keep whatever is in the fridge cold, be it your beer or your meat or your vegetables. Now, if you take that fridge apart with a screwdriver and a spanner and put all the bits out on the floor, the door and the contents of the fridge and the light and the motor, and you see it all laid out on the floor, each one of those individual components will not actually keep your meat fresh. It's only when you put them back together in a particular way that this property of those parts emerges, and that's called an emergent property. And being able to a priori define what an emergent property is quite challenging. So the kind of systems diagrams that we use for teaching at the undergrad effect, and also then once we go into postgraduate teaching, it doesn't matter if we're in health science or biology or physics or chemistry or mathematics, we try and get students to conceptualize both mentally and physically in drawing what the major components are, like forest mortality or the carbon sink. And then what are the arrows linking those different parts of the system together? Carbon sinks, increasing carbon dioxide concentrations, how does that feed back on warming? And you'll see there little positive signs and there's little negative signs. What those are the simple mathematics of if you have positives, lots of positive effects, you get an overall positive feedback. But however, if you're multiplying a positive by a negative, you get an overall negative feedback. So this is always the first step we take when we are asked to engage in a particular type of scientific problem in the biological sciences, environmental sciences, economic sciences, to have a look at what policy development will result in, and also how perhaps it may impact on social communities. And what we then try and do is to look at those causal loop diagrams, as we call them, into how they react or interact with the Sustainable Development Goals. And as you know, the UN have endorsed these various 17 Sustainable Development Goals, which have now been on the agenda for some years. Some people in this country take them very seriously, other people do not. There is a concerted effort in the country to try and coordinate research by societies like the Royal Society and others, but as well as the Department of Statistics, who have to report to national government about how various research activities and treasury activities are actually responding to the Sustainable Development Goals. So I'd just like to, put these on the table, because we are supposed to pay attention to these, but actually, what is the reality? So I was heavily involved in negotiating goal number 2, which is zero hunger. Is this a complete pipe dream in Africa, or should we just use it as a goal that we move towards? I know from my research and a lot of other work that's been done in the subcontinent, we are not going to get to zero hunger within the next 50 years. But they have put out these particular goals to make sure that people at least are aware of what has been considered as the key 17 priorities. And you can imagine what kind of negotiations we had around deciding what are the key 17 goals. And I think what they've come up with is useful, and people do engage with them, and they have a look at how their research activities contribute. In education, it's easy, because we all are trying to meet Sustainable Development Goal 4, is to provide good quality education. And then we try and get many of the other things like Development Goal 16 around peace and justice to make sure that we have just transitions. And of course, the current just transition debate is around out of coal and into renewables. So many people have redesigned these 17 goals into those that are particularly concerned with the biosphere, which is agriculture, timber, fisheries, etc., and then the societal goals, and then the overall economic goals. So there are different ways of dealing with that. Many people now try and take those different rings and see how the interactions are. For example, in my kind of research, we never do a project any longer that only looks at the biosphere, but we have to consider the societal impact and the economic impact. So I think it was useful in getting people to think in possibly a different way. So now I would like to move on to some of the aspects of global change that we work on. And I would like to especially thank my colleagues in the Global Change Institute at WITS. That's Francois Engelbrecht and Colleen Fogel, as well as my own group of postgraduate students who work in these particular areas. I put extreme events at the bottom because the frequency and the intensity of extreme events is changing. So if we go back to the title of Weathering Global Change, if we take that on a decadal timescale, then I'm afraid the impacts are going to be extremely negative. The extreme events are frequent and they are extreme. So we have to be able to assess when do we define them as extreme, and when and how quickly do we act in order to make sure the impacts are not as great as they could be. So I'm sure you are all familiar with what the current trends are in terms of surface temperature, which is on the left side of this graphic, versus the annual precipitation, which is on the right side. These are all data that come out of the International Intergovernmental Panel on Climate Change. And that's essentially the authoritative assessment on what is being observed. The more red the color on the left-hand side, all the way going across to the purpley color, is essentially saying it's getting hotter across the globe. The white areas is where we don't have sufficient data, to actually populate that particular part of the climate model. And the blue area up near Greenland is the only part of the world that's getting cooler. And that's because of the melting of the Greenland ice and therefore cooling the ocean. So we are pretty certain about these data. When we talk about global change data, you have to consider certainty. What are we certain about? At what confidence interval, and what are we uncertain about? We are good on temperature. Essentially, we are hopeless, but don't tell my colleagues unless they're here. We are not good at predicting changes in precipitation because it is much more complicated, because you have to do what are called coupled models between the ocean, the biosphere, the vegetation, and the atmosphere. And they are not easy to do, and they require huge computing time. But essentially in Southern Africa, in most of Southern Africa, it's going to get hotter and drier. But we sit in a particular position on the planet at this bottom end of the continent of Africa, which I said earlier has gone nowhere for millions of years. And we are surrounded by a cold current on one side and a warm current on the other side. And that actually changes a lot of how the different temperatures will be in our section of the country. So if we look at the projected change in the short term and in the longer term, the details are not important. The bottom right-hand slide says it's red, and it's much redder over the Kalahari area than it is over the rest of South Africa. So in other words, it's getting hotter, significantly hotter, and we are not moving sufficiently quickly globally in order to meet our IPCC demands. So what is well known about where we sit on the continent is that unfortunately South Africa will warm at twice the global average mean. So if the global average increase in temperature, that's a global aggregate, is 2 degrees, we will warm at 4 degrees. And 4 degrees is hot. I was in the Lowveld last week, and for 4 days in a row, it was 39 degrees and 80% humidity. It was not very pleasant, especially working in the field. The annual precipitation, the short story is, the most of Southern Africa is going to get drier, especially on our west coast. There will be areas, especially around northern KwaZulu-Natal, which will get wetter, and occasionally areas in the Eastern Cape will get wetter as well. And again, this is linked to the exact positionality of this part of the continent relative to the ocean currents and to the circulation patterns over Southern Africa. But as I said earlier, the uncertainty around rainfall is much higher. If I downscale this to some of the work we've done locally in a place called Witwatersrand, which is on the border of Mpumalanga and KwaZulu-Natal, we had a master's student looking at the long-term record. Unfortunately, we do have a long-term record of climate from this particular location. And this student, Imtor, he studied the increases in the maximum temperature, that's how hot it gets during the day, versus the minimum temperature, which is how hot it gets during the night. And over the century, the take-home message, and this is true globally, it is getting hotter at night. The minimum temperature is getting hotter than the daytime temperature. So if you didn't like frost, or you didn't like going out in the cool early mornings of Gauteng or wherever you're based in the country, well, you don't have to worry about that any longer. All nights across the country are getting significantly warmer, which changes the things like frost occurrence, fire frequency increase, and many impacts on industry as a result of these particular findings. And this isn't unique. It's well documented for all over the world that the minimum temperature is going up significantly faster than the day temperature. However, if we take the rainfall data for the same data set, it's what we used to call a current bun distribution. There's little dots all over the place, and you can put in a trend line, and it is decreasing slowly at 71 millimeters per century, but essentially of no significance. The only significant decrease in rainfall in South Africa over the last 100 years is in the Eastern Free State, which is where the maize production areas are in South Africa. And we have informed many of those farmers, for example, in the Senekal area, that the rainfall has gone down significantly, and we suggest strongly that they should move out of maize production, which is unfortunate because it's one of the breadbasket areas of the country. So this diagram is called the burning embers diagram, and I won't dwell on it, but those of you who are particularly interested in biodiversity need to look at these areas of where the most rapid change is happening and where the organisms in these areas are able to adapt or not adapt. So the Arctic and the Amazon are two critical areas where major economic impacts are going to take place. And unfortunately, as always, it's the global poor developing communities that are impacted by both cyclones and floods, of which we've seen numerous examples mostly in Central America and in North America and in our own KwaZulu-Natal just in this year, and what the associated risk is. So for some of you who really like to eat a lot of red meat, the beef cattle industry in South Africa is going to shrink dramatically. The profile slide on the left, where you have the yellow and the green, that shows where currently cattle can be grown on essentially the veld as free range. But as we get up to 2.5, which we're very close to already, an increase in our temperatures, the area gets constricted significantly. And as we get up to 5, there is going to be very little land left for where it's suitable for free range cattle. However, many of those farmers are quite adaptable in terms of switching from a combination of free range to feedlots, which is good for their livelihood, but not necessarily for the environment, because feedlots do not have a good impact on the environment because of the methane emissions from the accumulated dung. Impacts on water. So in South Africa, water supply is a problem, as we know, but quality is much more of a problem. So in South Africa, all our water resources are already fully allocated. What I mean by the hydrological cycle amplifies the climate signal is if we are getting a twofold or 1 degree increase in temperature, that gets magnified by approximately 3 times with respect to water. We are doing, as a kind of contribution to community outreach, which is an important component of ASSAf, we are testing water quality every month in a big range of municipalities across the country. The little bottles on the right-hand side, we have interacted with communities. We give them the necessary chemicals. They take a little water sample and they pop in a reagent. And if it turns blue, then they know that they should not, under any circumstances, be using that water for a drinking source. They could use, hydrogen chloride or bleach to try and clean up the water, but essentially they shouldn't be using it as potable water. So we're trying to do a number of projects in that area. Looking at food security, where we are in the country at the moment, we're nationally food secure, but certainly not at the household level. There is a huge divide between urban and rural. And unfortunately, all our policies on food security deal with people in urban situations, and they don't deal with the millions of people in rural situations and their food security. So it's a very stark example of where policy has had unintended consequences. It doesn't meet the needs of all the people who are involved in growing food for South Africa. However, we continue to have a lot of food wastage in the country, and if we can reduce food wastage, it would really enhance our food security. Some of the data we have from the University of Pretoria, that up to 37% of the food that is accessed, in other words, bought and paid for by people, actually goes to waste. So it's something that people are trying to work on. An issue that's emerged over the last few years is around heat stress in the labor force. So they are worried in South Africa, especially in those areas like the mining industry, and where most of your labor in the agricultural areas are working outside, and what the increase in heat exposure is going to be, and what various companies are doing about it, and what they are now required to do about it. So the health impacts for Africa have been quite well studied. And if you have a look at these, and those that are highlighted in red and the little asterisks, so extreme events, we know that our level of confidence is that extreme events on human mortality and morbidity in Africa are going to be high. And we know that, or very high. And then foodborne and waterborne diseases linked to water quality, which I've just spoken about. And then many of the waterborne diseases, diarrhea and cholera, are also a serious problem. And then, unfortunately, that many of the impacts which we don't think about every day are how health services are disrupted by extreme events and change in policy. Like the example I was giving you earlier, where money was moved from the Department of Health to the Department of Education, in that particular example, actually meant that many of our local clinics had to close down. So that was not linked to climate change directly, but it was linked to changes in policy. So that's why I work in systems analysis, to see what the potential impacts of various decisions will be on systems. And then we have never looked at this before, but we're now taking it quite seriously. There has been a very big change in the insurance industry around the world, especially linked to global change, and who now is prepared to pay for what. Premiums have gone up significantly. It affects all sectors. Heat waves, as you've seen in Gauteng, and depending on where you are in the country, are already quite extreme. And we have what we now call climate change refugees. We have people moving out of Pretoria, for example, to cooler parts of the country because it's getting too hot in Pretoria. And this impacts food security and trust. So when I came back last week from Geneva, from the World Meteorological Organization, I happened to sit next to a woman who was the head of the reinsurance industry from a very big company in Zurich. And she was in South Africa to reassess the mining industry and the potential heat impact on miners moving into the near future, the next 5 to 10 years in the Northwest. So people are taking this quite seriously. The research that we the approach to research is through developing a common vision. So no longer actually do we sit and say, well, we know what the climate potentially is going to bring us, who needs our knowledge, and how do we develop a common vision with them. So I would say all of the workers and all of the industries and all of the government departments where my particular research impacts, we always develop projects together. The one thing that concerns me enormously is this rise in skepticism. I meet people more and more frequently who have bought into local conspiracy theories. And part of me feels that many people these days, because they have not gone back to work full-time in an office, have a large amount of time to read, and they read without discretion. So the Journal of Junk Science has millions of followers, and the Daily Skeptic, now another journal, has emerged to deal with all the people who do not feel that climate change is an important issue. I would strongly advise you not to look at these various sources, because once you look, you are captured, and they will send you many, many hundreds of articles around climate change skepticism. So just going on briefly to what we are doing specifically, I work a lot with the forestry industry on rainfall over complex environments. I work a lot with both smallholder and large-scale farmers, mostly in mangoes, macadamia nuts, and avocado pears. And what we always believed was that the forestry industry could manage without high levels of research. And it's turned out that that's not true. The agricultural fruit, especially the tropical fruits, we ask questions around, if we go back to apartheid days, where we had large-scale farmers who were growing crops, and then over the last 50 years, 100 years, we've always had small-scale farmers. Do large-scale farmers and small-scale farmers interact? And it was very interesting to interview very large numbers of these rural farmers and to find out that the old apartheid divide has disappeared completely. Everybody, essentially, this is mostly in the Limpopo province, helps each other out. So this one sign here in the bottom right-hand corner says mangoes wanted. So what the small-scale farmers are doing is essentially they take all the mangoes, be they produced on large-scale farms or small-scale farms, and they take all the mangoes that are not really good enough for sale, be export or local scale, and there are now multiple chutney factories in Limpopo that use those mangoes to produce a very viable commodity, which brings those people a lot of money. So we've developed these causal loop diagrams. We always sit with the people and say, what do you want? What are you trying to do? How much pest and disease management do you have? Do you make juice? Do you just make acha? Do you export? Do you want to export? And we put this all together, and then these diagrams help us understand where a sensible intervention would be. What's happening in forestry is that forestry is a long-term crop, and we need to be able to predict 10 to 15 years from now in the areas in South Africa where forestry is grown. That's mostly pine and eucalyptus plantations. But how do we do that? And some of you may say, well, I don't care about forestry. All that does is use all our water. Well, actually, relatively, they don't use all the water. Sugarcane is the biggest water-using crop in the country, and it doesn't generate us a large amount of economy any longer because of the downplay in sugar globally. So we look at forestry because it brings us a large net amount of income from both paper and pulp and from timber products. So the hardest thing to do with respect to trying to predict rainfall for forestry areas, they don't usually grow trees on flat land. They usually grow them across an escarpment. So for example, the slide is from on the border of KwaZulu-Natal on what's called the Nkangala escarpment, and you have flat areas and you have areas going up an escarpment, and you can't take weather station data from 1,000 meters and aggregate it with weather station data from 1,300 meters, and then you can tell the industry, oh, don't worry, you're going to get enough rainfall. Well, too bad, you can't do that. So you need very sophisticated statistical techniques, probabilistic techniques, as well as downscaled models. And myself and colleagues in the GCI and my postgrads do a lot of that, so that we use these different modeling tools. They're proving to be very useful. We teach people in industry how to do that. We run an internship program to teach people in industry, research organization, and government how to use the data and how to especially use that data to reduce the risk in the industry, but also to make the industry sustainable. So it is important. And then the very last section of the talk that I would like you to think about and be reflective on. The first idea I would like you to think about is around a British economist called Keynes. And it's, Keynesian economics, which is a very well-known area of economics for those of us who work in that field, and I don't. But I think what was very important that came out of some of these thoughts early, back to 1946, is what and when is enough. So these ideas are all linked to the sustainability of the planet. So we have basic science, which gives us an idea of where the planet is going with respect to atmospheric chemistry and heating, rainfall, and impacts. And what about consumerism? And the social dimension is enormously important, but how seriously do we ask ourselves when and what is enough? And how do we define that? For whom, under what circumstances, current generations, future generations, as I've spoken about right at the beginning of the talk, of the definition of sustainability. So that's what I'd like you to think about, what and when is enough. And then there was a monk in the Bahiti tradition. He has been a spiritual leader, is based in America for over 40 years. And he talks a lot about you can have influence, but without affluence. And that's the power of integrity and authenticity. And what I am finding in a very wide area, particularly in South Africa, but not only in South Africa, in some of the international committees that I work on, people believe you have to be financially influential in order to have that financial affluence in order to be influential. And it's coming now to play in the IPCC agreements, in the negotiations. Who are you? What does your country bring to the table? What is your particular position? So, I urge people to think about personally, what does it mean to have integrity with respect to your science and its application, and you as an individual with respect to authenticity and your particular community. And then the third one is around affluence, but without abundance. So looking at, what is the definition of affluence? Many people just think about it financially. However, it's not only about that. It's about an alternative lifestyle value system. And there's a very interesting book written by James Sussman on Bushman behavior, which is completely centered on respect and humility within their community, but also for the environment. So I'd just like to stress those points. And then very finally, there's this famous quotation by Oscar Wilde that only personalities move the world, never principles. So I'd like you to think about that. Do you agree with that or not? And the role of basic sciences in finding solutions and contributing to the Sustainable Development Goals is absolutely paramount, is what I believe, because we need those in order for decision-making and policy development. And many of those things are principled. They're not only based on personality. I do understand his position that personalities make things move forward, but they can't make them move forward unless we have the basic science and those theories and principles of how basic science works. And then I would just like to say that ASSAf tries to play a very important role in making sure that there is rigorous science done in South Africa, and play a role in the advocacy of that science about to anybody, decision makers, other scientists, other researchers, other international organizations, about the importance of excellent science and community engagement. So thank you very much for listening to me.
Mary, that was really, really awesome and stimulating from the very beginning of the way you positioned the methodology of systems thinking and taking us through the examples, including those of your own research, was really, really spellbound. Thank you, thank you, thank you. I note also that you mentioned the just transition. And I just wanted to add to those people who are unaware that ASSAf does have a forum on the just transition, and that's chaired by Professor Harold Winkler and co-chaired by Professor Rasigan Maharaj. And just this week, we had a very stimulating engagement. And the nice thing is that the forum is open and engages with many of the active stakeholders from across the grid, and plays that role, as we normally say, ASSAf is like the gel that brings together various parties to engage on topics of relevance. So thank you for raising that during your talk, and I just thought I would raise the bar for the Just Transition Forum at ASSAf. Also, colleagues, tomorrow, in partnership with the Inter-Academy Partnership and NASAC, ASSAf is co-hosting the impact of climate change on food systems. That's scheduled to take place at 2 o'clock. So if you just go to the ASSAf website, you'll see that information. And I'm sure a lot of what Mary has told us will be re-echoed during those deliberations. So we encourage you to follow on that going on tomorrow. Colleagues, many of our members serve on pertinent fora, as Mary just mentioned, on the International Panels for Climate Change, but also on the Presidential Planning Commission. So we do have as members at least a voice, not just of scientists, but people affiliated with the academy across those portals of discussions. And Mary stressed the importance of communication to policy makers, but more importantly, to the general community through science engagement. And I think that that is one of the assets that we can bring as members of the academy to the community at large. And as I say, we do science for the promotion of science, science for society in recognizing the challenges among society, and science for policy. And we do it at varying degrees, but in an integrative way. So I will now, Mary, if you, because we have some time, open up the floor for some discussion and questions, should anyone who is still with us wish to ask Mary a question. You can just raise your hand and Renata will give you access, or if there's anything in the chat, I'll quickly go through that. Thank you also, Mary, for raising the International Year for Basic Sciences and Sustainable Development. I like the way in which you integrated the work that you are doing across the 17 goals and emphasizing the point that they're not standalones, but like a mosaic and intercalated network of bringing together the various things. And I must agree, as coordinated as we think we are locally, when I see what comes out of the Stats South Africa report and knowing what is actually going on, it's chalk and cheese. So, you know, we do the best we can, or the country does its best in the reporting, but I know that the reports have to be compiled in a particular format, and maybe a lot of what we are doing is underreported. I see a hand. Let me see who is, oh, Professor Eagle Gledhill. Renata, can you give Eagle access to the floor?
Hi, thanks. Am I audible?
Yes, you are.
My question is about climate finance, which I foresee is becoming more and more important. And my understanding is that it's fairly inequitable at the moment. Mary, do you see changes in the offing at all in terms of climate finance for highly vulnerable continents?
So yes, it is, thank you for the question. It is an area that is mired in politics. So the kind of idea is that the more influential you are, which often means the more financially influential you are, the more right you have, or entitlement you have, to come to the table to negotiate around the climate financing. However, that's not what many of the climate financing programs are trying to achieve. The climate financing programs are really trying to assess the risk, and I think an assessment of the risk and vulnerability in particular areas is a good way to go. It's very, it's easy if you live on an island and your country is going to disappear under increasing seawater level rise. It's easy then to actually quantify the risk, and they do give a significant amount of money to those particular small island states. However, it's the vulnerable group that's between the small island states and those that have essentially no financial influence. And that's where the major negotiation will take place. And as you know, there's COP27 coming up now in Egypt, and the financial instruments that will be available will no longer be equal. So somebody from the United States may not have access to a financial instrument that people, say, in Southern or East Africa will have. So they are looking at differentiated financial funding, but the negotiations are very tough, and you have to be able to stay awake for many hours in order to get through many of those negotiations.
Thank you.
Any other comments or questions? Anybody else working in the area that would like to share some of their experience with us around this topic? All right. Well, Christian, Perk.
Hi, Mary. Hi, Mary. Thanks a lot for a nice talk. My question is, since you said that basic science is essential for addressing the different goals, how do we convince universities, which are half companies, or if we look at to the US, which are actually companies, that they're investing that money into basic research? I mean, that probably extends then as well to governmental departments as well.
Yes, thank you, Christian. You raise a very interesting point, and I may say something that is not popular. I think South African scientists have relied far too heavily on funding for science from the NRF. And whereas there are a number of other organizations that receive funding from, be they very applied areas, and then they channel those through universities into both basic and applied sciences. So we have a few examples of where that works very well in South Africa, but not enough. And I strongly urge South African scientists to train their postgrads, because those are the ones that are going to need this funding, into proposal writing that will meet the needs of doing basic science, but at least with some immediate 10 years, 12 years application. And I think, you know, and I'm sorry if I put you all in the same box, but a lot of South African academics don't do that, and they certainly don't train a new cohort of people to be able to raise their own funding. So thank you for raising that, Christian.
Thanks.
Thank you. Julian May.
Thanks, Mary. I found that a very interesting presentation, and a lot of resonance with the work that we've been doing in the Centre of Excellence in Food Security, which is NRF funding, I'm sorry to say. My question picks up on your topic of wicked problems, because that's something which obviously fascinates us working in food security, because food security, as you pointed out, is indeed a wicked problem. It's further complicated, and not all wicked problems are collective action problems, but again, how the food system is managed is indeed a collective action problem as well. Now, what that means is that we have multiple stakeholders, and sometimes these are stakeholders who are in fact in dispute. They actually are in conflict. What benefits one stakeholder may penalize the other, and the stakes are very high. The food industry is a tremendously profitable industry, and yet also many times the cause of some of the problems that we are seeing in the food system. So I guess this is not a question about science. This is a question about science and the communication of science into the policy realm. What strikes me as important is the role of partnering, and how we bring together stakeholders who don't agree and essentially build partnerships that are difficult. It's not going to be easy. I'd be curious about your experience in trying to do that as a scientist, trying to engage with the policy world, any success stories that you might have, and any examples of catastrophic failure would be interesting as well. Thank you.
So thanks very much, Julian. You raise a very interesting point. I think what I've learned over probably the last 10 years is you cannot be dogmatic and domineering, which is, you know, my behavior. I wanted people to do it my way, but unfortunately that's not well-founded. So, you know, now having been formally trained in systems analysis, if you are able to draw causal link diagrams, So what we now do is often run within your program, be it food security or be it forestry, and I have had a lot of success within the forestry industry, is to bring the various industrial partners, research workers, climate modelers, and government people to talk around building those causal loop diagrams. So you get these, you know, kind of senior people who think they know everything to actually sit down with pieces of paper and work in groups of 2 or 5 and draw a diagram as to how they see this, the system. And then they sit and argue it out. So it's a technique called the World Cafe exercise. They argue it out, and then you pull all those bits together. Hopefully during the arguments, what it results in, or you ask the people to focus on where would, if you broke the connection in your causal loop, would the system become catastrophic? So that often helps in conflict resolution, because many times people want their little arrow or their little voice on the table. I'm sorry, I don't want to be derogatory, not their little voice, their voice on the table. But actually, if you broke that link, it wouldn't result in catastrophic impact. So you get people to agree where are the strongest links. And quite often you go from having a laundry list of 30 things that are linked to each other down to 4 or 5. And whoever's facilitating that discussion is wise enough to you know, bring the discussion together to make sure you're focusing on the strongest links. And then you look for interventions on those strongest links. And quite often I found in the industry, the forestry industry, what was most important at one stage was how you grew trees. And then the other one was how you marketed them. And then the other one was whether you turned it into pulp or whatever. But once they saw the system of that growing a tree actually results in a product that is either good for pulp or is either good for laminated timbers, they could then see where the impacts were if you changed the whole system. And I must say that working together in this co-production of knowledge way, by starting at the beginning with the people that are influential, be they financially influential or socially influential, in an area, it actually resolves things that would have arisen as conflict 2 years down the road.
Thank you very much, Mary, for sharing your insights and for taking all the questions, and to the members who've asked these questions. I think it just added that nuance of steering the ship a little bit further. Colleagues, we've come to almost the end, and I want to take this opportunity, Mary, on behalf of all of us, to sincerely thank you for giving us a very thought-provoking presentation today and sharing, you know, with such intuition, your collective, you know, experience in this field, and bringing home the poignant messages on how we as individuals should be living, you know, in our macro environment, and taking heed of the many challenges we have, and to use evidence-based science to approach the many challenges and provide some solutions. I think your research and that of your team and collaborators give us very good guidance on how to align future thinking on our very important questions. Colleagues, I want to thank you all for your patience of staying with us. And I also wanted to re-emphasize the importance of us using basic science in addressing, you know, the Sustainable Development Goals. You know, we are celebrating the International Year for Basic Sciences for Sustainable Goals this year. It was launched in July. ASSAf had its own launch on the 25th of August. and ASSAf is the focal point for this initiative, supporting the DSI and the NRF in the venture of bringing those messages home, which we will continue to do under the steering of my colleague Ina Smith. So she does report on these activities in our newsletter. Colleagues, we've taken a lot of attention and pride in trying to package the operational activities of the Academy in our quarterly newsletter. I know you have lots and lots of more important things to do, but at least once every quarter, when you're sipping a coffee, watching the sunset, or if you have your glass of whiskey in hand, just peruse our newsletter, just so that you know what it is that we do. And we are not anyone without you. So we value your participation, we value your interest and support, and we are very, very grateful that we have this National Academy to steer what we believe are essential issues around academic support. And I would just now like to bring in Professor Jonathan Jansen as our president to have the final say. Over to you, sir.
Thank you, Yimla. Finally, thank you all for attending. Without you, there is no Academy. I appreciate the group that has stayed till the end. Once again, thank you to Yimla and the team for giving us an Academy that has done so much with so little in terms of resources. Thank you, Mary, for making accessible a complex science for those of us who don't work in your disciplines. Yesterday, I was a speaker at Thuli Madonsela's annual Social Justice Conference on the subject of social justice and restitution. And I was very struck by a chap called Angelo Fick from, used to be at Wits, I think, saying, what's the use we talk about restitution, such as, for example, land reform, when we have effectively run out of time? That is to say, we're still talking about making up for the past with, and if I heard you correctly, when the available land is in fact shrinking. And it just seems to me that we sort of hung up on, tropes from a struggle past that needs to really be rethought in the context of environmental damage and climate change. I was in California a few months ago when friends of mine were planning to migrate from the Bay Area to Seattle, to Washington, in anticipation, of the devastation that is already there with regard to climate, the fires, all of that, and going into the cooler Northwest. So these issues are real, and if Mary's talk did anything, it is a Himmler for us to place this issue of climate change, environment, and so on very high on the agenda of ASSAf in the years ahead, because, as my colleague said yesterday, we are running out of time. To all of you, thank you, and have a wonderful evening.
Thanks, Jonathan.
Thank you all. Take care. Bye-bye. Thanks, Mary.
Thanks, guys. Go well.